First of all, I'd like to thank you very much for joining our webinar this morning or this afternoon for OT to IT and the cloud. So the logistics, you're currently on mute. If you have any questions, please reach out through the Q&A. If you have any immediate concerns, please hit the chat. So copies of this presentation and the webinar link will be emailed to you after the presentation. Normally it takes us a day to 2 days in order to get it out to you, but you will get a copy of this presentation as well as a copy of the slideshow deck and also access to the other webinars that we've done over the last 6 months. So we're going to cover quite a bit today, so I'll just cover it really quickly. So we're going to talk about what are the risks of IoT, what are the risks associated with OPC networking, how the DataHub helps, MQTT and how the DataHub can help you with that, as well as we're going to go through a live walkthrough of the DataHub, best practices, about Skynet, and then we'll cover some case studies. So let's start right from the beginning. What are the risks of IoT? So recent cyber industrial attacks tell us that, in fact, when you don't secure your OT network, there are some serious risks. And we can see that in last year and also the year prior, where Homeland Security confirmed a ransomware attack on the US pipeline. So we've had 2 in the US that we know of. Honda was attacked. Japanese car maker was attacked on a global operations scale. And then finally, last year, we also had a hacker who tried to poison the water supply in Florida. So these attacks are actually increasing in volume. And so as a result of this, governments are starting to get involved. We saw in the US, they're doing joint press releases, NSA and CISA. They also did additional releases last year and also this year to warn people to really, you need to reduce your exposure on your operational technologies. In Europe, they've just revised the Directive on Security and Network Information Systems. It's now called NIS2. And the key guideline is really to have 1 or more DMZs for the most secure and manageable and scalable segmentation of the control and corporate networks. When we look at what are the lessons learned, what we find is that not implementing segmentation provides a method for people to break in. And so once they get into the IT network, they can break through into the operations network to compromise your HMIs, your data historians, your polling servers. PLCs are rarely impacted, although we have seen that in the past. And then international companies, the impact is not geographically limited. Once they're in the network, they can compromise all of the network. It all really starts basically on the network topology. So if we take a step back and look at ISA 95 or the Purdue model, the truth is you need to have this segmentation, these firewalls between your segments of the network. And so there's a bit of a challenge here, because if I am trying to access an OPC server from, say, an IT or OT network, I have to open up that inbound firewall port to subscribe to the data, because the client connects to the server. And so what some companies do is they'll say, well, we'll implement a VPN. By implementing a VPN, you're actually bridging the 2 networks together and bypassing the firewalls, which actually makes it worse, because now anyone on the VPN has access to all the resources on both the networks. So let's take a minute about talking about OPC networking. So we talk about a OPC network, we basically have a source and we have either a cloud or a client. And so I have my OPC UA or DA server, and this could be Modbus just as well, where I'm actually needing to get that information from the subscriber. So in order for the client to connect to the server, I need to open that inbound firewall port, which requires, a sense of risk. Now, I can put a VPN in, but as we talked earlier, it's not an adequate, proven solution to access data. So we can add a DMZ into the situation. By adding a DMZ, we now have the DMZ connecting into the plant source. Again, I have that open inbound firewall port, and then from the cloud or the client, I am then connecting into the DMZ. So here, I'm opening up a firewall port in the DMZ, but on the plant, I still have that open firewall port, which is not secure. And so I can put in a VPN, but again, not a secure solution to the situation. Key thing to note is the big arrows represent the connection path. The small arrows represent the data path. So that can be data going bidirectional or unidirectional. So how does the DataHub help in this situation? Well, the DataHub mirrors the data from the control network to the DMZ. And so it acts as an OPC client to the server and then mirrors that data into the DMZ outbound. So no longer are we constrained by the client having to connect to the server. This DataHub can choose who initiates that connection. From the cloud connection or from the remote user, now we have an outbound connection to the DMZ. So the DMZ has open firewall ports in order to establish or connect to the system, but each of the networks are completely isolated, whether it's the user or the cloud. They don't have access to the network. So the network is isolated from the cloud and to the plant. One other option that's come up often is MQTT. And so we'll take a minute and talk about MQTT and what does that mean in terms of security. So, MQTT is a publish and subscribe messaging transport. It's lightweight, it's bidirectional, and it offers 3 defined security levels. So level 0, which is at most once, level 1, which is at least once, and level 2, exactly once. So what does that mean? 0 means I fire and forget. Level 1 means you're going to get it at least once, but you might get it more than once, the data. And then 2 is where you will get the data exactly once. And so 2 is kind of the ideal solution when you're moving, but not all cloud providers provide level 2. In fact, no one does. They all produce level 1 or provide level 1. So what are the advantages? The first one is when I'm publishing to the plant, from the plant directly to a cloud broker like Azure or AWS or Google, it's an outbound connection. So there are no open inbound firewall ports on the plant network. But the problem is that network segmentation in the plant means that most plant networks do not have access to the internet. And so in order to map to the cloud, I would have to network map to an external connection, which in most cases is not allowed. So then the other option is, let's talk about moving the data from an MQTT client in the source and bring it into a DMZ. Well, okay, so yes, this works great. I have my DMZ. Now the DMZ is acting as a broker. I have no inbound connections on my plant. But in this environment, it would require the broker or the cloud to have an MQTT client. And so most cloud services are not clients, they're brokers. And so this will not work if I'm connecting to a public cloud. The other option is to take the plant source, bring it into a DMZ, and then from the DMZ, take it to the cloud. Now, most cloud services are brokers, so this doesn't seem to be a problem. I have no inbound connections on my plant, so there's no issues here. The network seems to be bridged, but the problem is when it comes to MQTT broker chaining. So I have a client connecting to a broker who's also acting as a client to a broker. And so the quality of service between the first client and the first broker and the second client to the second broker don't bridge very well. And so I can have situations where data isn't coming in the right order, and that can create a problem. Remember that the cloud broker is normally a level 1. And when it comes to source, I can choose level 1 or level 2. Whichever one I choose, it still creates a connection daisy chaining problem between the two. So how does the DataHub help? The first step is we can take the data, we can mirror it from the plant source and bring it into the DMZ. Once it's in the plant into the DMZ, we have that isolation between the plant network and the DMZ. We can now publish it to an MQTT broker. So there's no inbound firewall ports on the source. The cloud data connection is outbound. So again, we don't have a connection path into the DMZ. There's no inbound firewall ports and there's no VPNs. Very simple connection. Any data that appears on the plant source is mirrored to the DMZ and then published to the cloud. Let's take a look at a live walkthrough of the DataHub. So just give me a moment and we'll get things going. What you're looking at is two instances of the DataHub. The first instance of the DataHub is sitting on a VM, a virtual machine. That virtual machine is connected. There's a data source that's being published to it from a secondary PC. So that machine is actually not, you can't actually see it, but it's actually sitting on a separate machine. I also have DataHub running locally on my machine. And so DataHub locally on the machine is connected to the DMZ. And so let's take a look at that for a moment. So I have, if you take a look at my tunnel connections, I am showing no tunnel connections, and yet I do show two connections to the DataHub. And so how that's working is that I've connected to a data source called remote 1. I can see that data is traveling in real time. If I disconnect that DataHub, you can see that it's now disconnected. If I reconnect the DataHub, you can see the data is now flowing freely. So as a broker or as a DMZ, the DataHub is consolidating data from this one point, but in theory, it could be from multiple points. And so all of that data would be available in my data browser. On my data machine, on my actual physical machine, I can see, for instance, there's remote 1 and there's the DataHub. You'll notice that the data is traveling at the same frequency. I can see good as the connection path. Now, because I've configured this as bidirectional, I can in fact change the frequency. So by changing the frequency to 1, you can see that I've changed the frequency on the DataHub running in the DMZ. I've also changed it on my source machine. If I go back to my source machine and change the frequency back to 10 and apply that change, you can see that now I've actually applied that change across the chain. So a full mirroring of the data between the DMZ, the source data, and the endpoint client. Everything is clear and simple. We don't see any issues here. So the next step in the equation is what if I were to talk about MQTT? So as a DMZ, now I want to connect to a cloud. I want to connect to a broker and take that data and bring it up to a broker. So I'm going to look at an MQTT client. As an MQTT client connection now, I would add a connection. And just to give you an example, I can do standard MQTT, I can do Azure, Google, Amazon, or Spark-Plug-B. And all of these are built into the DataHub, and it's just a matter of deciding how you want to connect. If I'm connecting to Azure, I can say, look, I want this to be bidirectional, so I will subscribe to cloud to data device events. If I choose that it's just going to be one way, I can lock it down in that particular fashion as well. So for this demonstration, what I'm going to do is I'm going to say I'm going to be a Spark-Plug-B client. So, and before I do this, I just want to explain the difference. MQTT it's a relationship between the client and the broker is one-to-one. So the client connects to the broker, and then the broker, I have other clients that can subscribe to the topics that the first client generated or published. If the first client, such as this one here, disconnects, the broker is aware that that one disconnected, but the topic information, any other clients that are connecting to the broker, they're unaware that the data is bad, or they're unaware that the connection status is bad. And the reason is because it's a one-to-one relationship. The second client is connecting to the broker one-to-one. It's monitoring its connection. The first client is doing the same. And the last will and testament message is actually published to a different topic in the broker, which is not seen by other clients. And so with Spark-Plug-B, that changes a bit because Spark-Plug-B has this concept of connection aware. It is very defined in how it defines its architecture. So from that perspective, I have a different concept in Spark-Plug-B called edge of network devices, a primary application, and a non-primary application. So in an edge of network device, I'm actually at the edge. I'm creating data or sending data from my edge to a broker. As a primary application, that's normally considered the endpoint, normally a SCADA system, or it could be a logger, whatever, or a historian for that matter. In the primary application, its job is to make sure that the connections are there. It's making sure that the data is flowing. That's its job. A non-primary application, normally like a logger, or if I'm taking data from Spark-Plug-B and I'm publishing it to a cloud, it would be considered a non-primary application. It has no say, or it can't communicate directly with the edge of networks device to say, I don't see you, so send me a birth message. At the end of the day, the non-primary application just listens. So in my case, if I set myself up as an edge of network device, I would set myself with a name, a node. I would define my label, my host IP where I'm sending to, and then I would define the data that I want to bring across. So in this case, I might say I want data PIN. So as an example, I actually created one. And you can see, for instance, that I've set myself up as remote 1, an edge of node. I've set myself with my IP address to make myself available. And I've already set up my data points, if you will, that I want to transmit. Once I've done this, I can enable the connection. And going back to my machine on my local desktop, I'm now set up as a broker. So my broker has been enabled. I'm listening on the same port, and I'm waiting for messages to come in. And so now if I view the data, and you can see that I now have a new data path, which we had defined earlier, and there's the data. If I pause the data is paused. If I start the data again, it now appears. Lo and behold, the data is now started again. And this too could be bidirectional. If you set this up with bidirectional, you should be able to change the value and it will update the frequency of the data in the path. No different than running a tunneling connection. The only difference is that now we're using Spark-Plug-B as the transport protocol. So what we've covered is we've covered the DataHub as a broker. We've covered the DataHub as a client. Over here, we've covered tunneling in terms of mirroring the data from the DMZ into the DataHub. And you can see that I've set up a connection. So I'm going to take a minute and talk about that connection for a second. I've said to the system that this client is going to connect to my DMZ. I'm going to do this with a remote user, a password. I'm going to use secure SSL. Now, normally in a production environment, you would be checking off these two boxes, but I don't have a certificate. So since I don't have a certificate, I would just be rejecting all my connections. I've chosen the data path to be read and write, but I could have just turned around and said it's read. I could have said write only as well. Now, because I am collecting data from the master, which is in the DMZ, I'm telling the system, get all the values from the DMZ, and if my connection fails, mark them as not connected. And so again, I'm reaching into the OPC server, I'm collecting all the data points, and I'm saying, this is the data set now. I'm the authoritative voice of the data for the next connection that's coming in. And that's really about it. Pretty straightforward, not complicated. I'm going to jump back into the presentation now, and we're just going to go through, we'll finish up on the last two topics. So best practices. To prevent cybersecurity using the DataHub, there's a few things you need to do. So, you need to keep the firewall ports closed. So the DataHub allows you to do that. You can eliminate your VPNs on your control network. So an interesting story is a few years ago, I was doing a presentation at the ARC, and there were probably 80 people in the room, and I asked them, how many of you have a VPN in your control network? And I would say 80% of them had one. Today, if I were to ask the same question, I would tell you that chances are less than 20% would have it. That's a key component. You need to eliminate your VPNs. Segment your network from level 0, from level 1 to level 5 with firewalls. Use DMZs whenever possible, bridging between network layers. So if you're moving from level 2 to level 3 or 3 to 3.5, having that DMZ is critical. Never provide internet access in the control network, including mail servers. Mail is the easiest way for people to steal credentials. So whether you're connecting to a cloud or connecting to a mail server, this is the one thing you need to have disconnected. Keep your firmware and software up to date. If I look at our software, we're version 10 today, version 9 to version 10, there have been tremendous improvements in security. Having your software up to date is important for a long-term strategy. Back up your systems and disconnect your backups from the network. No sense in having a backup system connected to the network because it too will get the virus if there is one. And then have a plan in place. You know, the old saying goes is that you should always plan for the worst. The fact is that if you haven't been hacked today, the likelihood is at some point in time you may get hacked. So have a plan. When it comes specifically to the DataHub installations, we always say installations should only be accessible by administrators. Users should be restricted from the installation directories. On the tunnel master, disable your plain text connections, install a valid certificate, create usernames and passwords, and disable connect permissions for autonomous users. And this is important because now we have only required users accessing the DataHub. On the tunnel slave, enable SSL, reject your invalid certificates, reject your hostname mismatch, and configure the connection with username and passwords. Doing this will prevent anyone from breaking through. And that's really the key. So a little bit about Skynet. So today we have over 21,000 implementations in 86 countries. We are used by 10 of the top 10 automation providers. We're a certified Aviva technology partner. You'll find many of our case studies on our website. We have OEM relationships with many hardware and software providers, covering energy, discrete manufacturing, water, wastewater, building automation, oil and gas, minerals and mining. The DataHub is one unified application. It's a plug-in architecture that can connect to virtually any industrial system. Whether you're connecting to OSI Pi or Aviva Historian or InfluxDB, we can bridge your historians from one to the other. We work with OPC, UA, DA, A&E, alarms and conditions, alarms and events. We have .NET applications. And the key here is all of the data coming into the DataHub is one unified data set, which is then available to any other plugins that you require for the systems that you're doing. We cover server-to-server bridging, aggregation, data logging, redundancy, and we can connect to any cloud connection. In terms of case studies, one that was a couple of years old was real-time monitoring of the Trans-Enoleum natural gas pipeline. It's over 1,850 kilometers. It covers 2.1 million data points running in redundancy for alarms and events. It's real-time information, it's scalable, and it's a secure architecture. The key behind this product is that, in fact, we're connecting two different vendors to the pipeline. And so whenever one vendor was connected, the other vendor was aware that the other was connected. So they could actually see who's connected and who's not. ABB Italy, so we had a situation here where we have a power plant. They need to have a secure solution to network the data to their corporate network. And so the key here is they're using tunneling with an encrypted SSL connection between the two locations so that they could actually monitor and control the plant remotely. We have another example of tunneling and aggregation. Networking OPC data across firewalls. The SCADA systems needed to be aware of the OPC server. So two separate SCADA systems, they're running data connections and redundancy so that each one has real-time information from either one. And then close to home, Montreal, we had a situation where we had 6 different satellite stations. Now, their requirements are a little bit different. They didn't need to actually have write-back capabilities. They just needed to share the data with third parties. And so at any time, the third party could not, in fact, change data sets. They could just view the data. Some of the locations required redundancy, but the key is the data was coming in, they're logging it into a database, and they are making it available to third parties. So take the time, visit our website. If you haven't had a chance to see our website, and take a look at cogentdatahub.com. You'll get more information on our Connect to Secure OT to IT on our website directly. You can download the software right from our website. You can check our upcoming webinars. Now, I know you signed up for this one, but we also will be putting on webinars every 2 weeks. Some of them are more informational, such as this one, but we also have some technical webinars coming up specifically to some of the features of the DataHub. So we do wish, if you have a chance, sign up. You'd be interested to see some of the stuff we're able to do. So without further ado, if there's no other questions, or if there are no questions, I will close out the meeting and give you another 15 minutes of your day.